Yes. I'm going to, you know how there was not nice notation for adding, subtracting, multiplying, dividing? The composition of functions also has a not nice notation, and it looks like this. Instead of, this is the nice notation, saying that g of x is inside f of x. You do the inside first, get that number, and then do f of that number. The not nice notation does f, and it does a g, and then it uses something like a degree sign, but right in the middle. And this is the unclear notation, the foggy notation of this. So if you see this notation, change it to this. But that would be like in questions that we did, this on an exam might look like this. F of, and you read it, f of g of -1. Then I would change it to this and solve it that way. So it's just something also to be aware of. And we had done numbers with the table of values. We had done numbers where you got the values from the graph. We did equations where you got it from an equation. And what we're going to do today is, wait for it, there we go, is think if you had, right, two machines. Part A says first you plug it into G, whatever would come out would then go into F, and you would get a final answer. Okay? And at the very beginning, when we talked about having the machines in your garage and having one of them explode, you had to go out and buy a new machine that did both of those together. So the idea is, well, if I put in a number, and I don't want to do a lot of mental math, so I'm going to put in 0. If I put in 0, it would go into g of x, and you see that output comes 7. And then 7 would go into f, 7 squared 49 times 2, 98 plus 1, out would come 99. So I'm looking for a new machine that you plug in 0 and just do all the math, and out would come 99. What equation would go into this machine? And the idea is as follows. You just put x in. If you put x into the g, whatever would come out, it would double it, just like every other number, and add 7. Out would come 2x plus 7. And if you put 2x plus 7 into f, the rule for f is whatever goes in gets squared, you double that, and then you add 1. If I simplified that, that's what would go inside this machine to do it all at once. That's the idea. Now, mathematically, you're not going to like draw little machines, although you can if you want. But what we're going to do mathematically is we're going to say, okay, I'm going to start with f of g of x. I know that I can replace the g of x, because that rule is whatever you put in gets doubled, and you add 7. And then the rule for f says whatever you put in gets squared, gets doubled, and then you add 1. And if we simplify this, this would be 98 plus 199. Now this question says determine the explicit equation. So an explicit equation is just in terms of x. That's what we've done. We found the machine that would do it all at once, rather than having two separate machines working separately. And it asks us to find the domain and range. Now since this is a parabola, the domain of this one you could do without a calculator. Parabolas have a domain of everything. The range of this one you would have to graph, and graphing this would be tricky. So some of the questions in the textbook, if they're asking you about range, they're actually expecting that you have a graphing calculator. So if you have a graphing calculator, I go to y equals, I type in the 8x squared plus 56x plus 99.
Is it possible that in the exam that we need a graph?
No, you are not allowed a graphing calculator on the exam, just a scientific calculator. But you will need to know how to do these things for the AP course next year, so it is good practice. You hit graph, and then above the trace button is calculate. You can calculate, in this case, we want to find the minimum, go to the left of the minimum, push enter, go to the right of the minimum, push enter, enter again, and we get it's at 1. So my range is from, either you can write y is bigger than 1, or you can write an interval notation from 1 to infinity. So on a question like this on the exam, they would probably only ask about the domain, because the range is too much work. If the range is possible just using transformations unit or another unit that you've done, it is a possibility. So let's look at b and g of f of x. F of x was, whatever you put in is 2x squared plus 1. And then g of x says whatever you put in gets doubled, so 2x squared plus 1 gets doubled, and then you add 1. So this becomes 4x squared plus 2 plus 1 plus 3. No, I did that wrong, didn't I? Yes. I'm just noticing that it was the same equation. It's 2x plus 7, not 2x plus 1. So it's going to be 2, and then we plug it in, x squared plus 1, and then it's plus 7. Does that look better? Yes. And then, what do we have here? This is going to be 4x squared plus 2 plus 7 would be plus 9. This one, again, you could do the domain without a calculator, is everything. And this one, you could do the range without a calculator. Because in transformations, what's happening? This is a regular parabola, vertical stretch by 4, and then shifted up 9 units. So your y value would be greater than or equal to 9. And then C, we have g of x. So the explicit equation here, first of all, g of x is 2x plus 7. And then if you plug 2x plus 7 back into g, the rule for g is whatever you put in gets doubled. So 2x plus 7 would get doubled, and then you add 7, which gives me 4x plus 21, which is a straight line. Again, this we could do without a calculator. We could get our domain is everything, and our range is everything. All right, circle questions 10 and 11. And of course, this question could have looked like this. Of G. And you'd have to know, oh, that's composition of functions. That means G of X. You know what would be really confusing? If they had this.
Oh.
That's problematic, isn't it? Doesn't that look like log of x? I made my, this is probably too big of an, it should be, there we go, that's better. That's much less confusing, right?